Scientists claim that the universe began with an event known as the Big Bang, which occurred roughly 13.7 billion years ago. But the lingering question is, what triggered that explosion, and why did it happen? Over time, we've delved into the science and history of our universe, and the Big Bang Theory has stood as the primary explanation for the phenomena we've observed. Numerous studies and countless scientists have worked on gathering research, and the collected data consistently supports the Big Bang Theory as the principal explanation for how the universe came into existence. According to this theory, dark energy, a form of energy even more prevalent than galactic energy, is seen as the anti-gravitational force that has been driving the universe's expansion ever since the Big Bang. Science today is vastly different from what it was in earlier times, and with advances in technology, new theories emerge. Many times, we find that what we previously thought was entirely true is not the case at all. Michio Kaku has even proposed the formal debunking of the Big Bang Theory, partly because the James Webb Space Telescope has detected 750 new galaxies that look completely different from what scientists had expected. This discovery presents a fresh perspective, encouraging us to investigate how the James Webb Telescope is reshaping our comprehension of the entire universe. Join us on this exciting journey beyond the observable universe, and let's explore the newly discovered galaxies in greater detail. If you're keen on staying updated with the latest universe-related news, subscribe to our channel, like this video, share it to reach a broader audience, and activate notifications for new updates. The images of new galaxies taken by the James Webb Telescope are simply breathtaking. In just one picture, we can observe hundreds of galaxies, and the magnificence and grandeur of these photographs are truly remarkable. Yet, what's astonishing to researchers is quite different from what might surprise the average person. While these images are awe-inspiring to the scientific community, they don't align with the expectations based on current theories. In fact, the number of galaxies observed is much higher than anticipated. These galaxies are also smaller than expected and exhibit ages far more remarkable than imagined. These surprises are sparking a sense of alarm among scientists, with even an article beginning with the word "panic" in its title, underscoring the gravity of the situation. These galaxies defy everything that was predicted based on long-standing theories. For many years, scientists proposed the Big Bang Theory as the central explanation for the origin of our vast universe. According to this theory, around 13.7 billion years ago, the universe originated from a mysterious cosmic event. However, the newly captured images challenge the long-accepted narrative of the universe's birth. The images from the James Webb Telescope are shaking our understanding of the universe's origins, particularly since they seem to contradict the Big Bang Theory, which has been regarded as an unquestionable fact by most cosmologists. The galaxies seen in these images are surprisingly small, smooth, ancient, and far more abundant than predictions based on the Big Bang Theory had suggested. The observed galaxies are also 2 to 3 times smaller than those captured by the Hubble Space Telescope, which completely contradicts the expectations set by the expanding universe hypothesis. According to this theory, as the universe expands, objects should appear larger with increased distance. However, the galaxies observed by James Webb appear to contradict that idea. Furthermore, the smoothness of these galaxies was not anticipated. According to the Big Bang Theory, galaxies should display irregularities and structural variations due to the dynamics of their formation and evolution. However, the images show galaxies with unusually smooth structures, lacking the level of roughness and complexity that would typically be expected for galaxies of their age. This challenges the anticipated timeline for the formation and evolution of galaxies as envisioned in the context of the Big Bang Theory. In the early universe, all matter, energy, and the foundational elements of the cosmos were compressed into an extremely dense point known as the singularity. At this moment, the density reached an infinitely high value due to the extreme compression of matter and energy. The concept of the singularity is rooted in our understanding of physics, particularly in Albert Einstein's general theory of relativity. Within this singularity, all the matter and energy of the universe existed in a highly concentrated form. The incredible density suggests that an immense amount of mass and energy was compressed into an infinitesimally small space under immense pressure. In such extreme conditions, the temperature inside the singularity would surpass any imaginable or measurable temperature we can understand today. Within this hot, dense point was the very origin of everything in the universe as we know it. The singularity marked the start of the cosmos, from which everything emerged. After the singularity, the universe began its expansion and inflationary period, which occurred over approximately 13.7 billion years, ultimately giving rise to the universe as we observe it now. The expansion of the universe started with a rapid, enormous burst known as cosmic inflation. During this phase, the universe expanded far faster than the speed of light, stretching space itself and pulling everything along with it. Cosmic inflation played a pivotal role in forming the large-scale structure of the universe, smoothing out irregularities, equalizing the distribution of matter and energy, and setting the stage for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of its expansion gradually slowed. It is important to note that while cosmic inflation was a brief period of rapid expansion, the universe continued expanding at a measurable rate, a process known as cosmic expansion. Scientists have studied the evidence of this expansion, including the redshift of light from distant galaxies. Redshift occurs when light waves stretch out as the universe expands, shifting them toward the red end of the spectrum. During the expansion, all the matter that makes up the universe was compressed into an extremely small volume. It became apparent that matter could not survive in such a compressed state, so transformations took place as the universe expanded and cooled. In this early phase, particles like protons, neutrons, and electrons began interacting with light and energy, which played a crucial role in the formation of matter in the universe. During the first minutes following the Big Bang, this process, called nucleosynthesis, involved the creation of basic elements. Chaotic and disrupted galaxies formed by multiple collisions were expected to be observed, but the James Webb images present a different narrative. Instead of chaotic, colliding galaxies, the telescope captures well-organized, disk-like, and spiral-shaped galaxies, similar to the ones we see in the present-day universe. This unexpected finding challenges the assumption that mergers are a fundamental part of galaxy evolution. If these galaxies have not undergone many, or any, mergers, it becomes unlikely that small galaxies would grow into massive structures as originally predicted. This suggests that these galaxies might have always been larger than expected. Additionally, the optical illusion predicted by the expanding universe theory, where objects appear smaller due to cosmic expansion, does not hold true in this case. Thus, many of the concepts we previously held to be true may no longer be accurate. The discoveries made by the James Webb Space Telescope, JWST, have opened up a new chapter in the study of the cosmos. The level of detail in its images and data is extraordinary, revealing previously unseen aspects of the universe that challenge long-standing theories. These revelations suggest that the universe may have a more complex and multifaceted history than we have understood up until now. The JWST's capabilities allow it to probe deeper into space and time, unlocking the potential to answer some of the most profound questions in cosmology. One of the most significant aspects of these discoveries is the way in which they complicate the Big Bang theory. For decades, this model was considered the most reliable explanation for the origin of the universe. Yet, the recent findings of galaxies that are older, smaller, and smoother than expected raise serious doubts about its accuracy. The fact that the JWST has uncovered these galaxies, which appear to be far more mature than anticipated, suggests that the processes that led to their formation might have occurred differently from what we've assumed. This directly challenges the idea that galaxies formed gradually over billions of years through mergers and collisions. As scientists continue to analyze the groundbreaking data from the James Webb Space Telescope, JWST, new revelations emerge, further challenging our conventional understanding of the universe. The telescope's latest findings suggest that some of these ancient galaxies possess an unexpected structural complexity, spiral arms and well-defined disks that should have taken billions of years to form according to traditional models. These discoveries are not only forcing scientists to reconsider the timeline of galaxy formation, but also raising fundamental questions about the very nature of cosmic evolution. If these galaxies did not require the expected billions of years to take shape, could it mean that the forces governing the universe operate differently than we have assumed? Could alternative models of cosmology, long dismissed, now warrant reconsideration? Amid these debates, a new challenge arises. JWST's deep-field observations have revealed what appears to be a massive cosmic structure, a vast network of galaxies and interstellar material stretching across billions of light-years. This unexpected finding is difficult to reconcile with the concept of an evenly expanding universe. The structure suggests that gravitational interactions may have played a far more significant role in shaping the early universe than previously believed. As the scientific community scrambles to interpret these anomalies, some theorists propose a radical idea. What if the universe did not originate from a singular Big Bang event, but instead emerged from a series of interconnected cosmic phenomena? Could there have been multiple bangs, or a continuous cycle of cosmic rebirths? Meanwhile, astronomers are eager to push the JWST even further. Plans are already underway for an extended mission to focus on the edges of the observable universe, regions where light from the very first stars might still be detectable. If successful, this research could reveal whether these early celestial bodies align with the predictions of the Big Bang model or further complicate our understanding of the cosmos. As each new discovery unfolds, one thing becomes clear: we are standing on the precipice of a paradigm shift in cosmology. The universe is proving to be far more mysterious, ancient, and complex than we ever imagined. And with the JWST continuing to capture breathtaking images, we are only beginning to uncover the full story of our cosmic origins. As the James Webb Space Telescope, JWST, continues its observations, it captures something even more astonishing: anomalous cosmic signatures that defy known physics. Deep in the fabric of space, beyond the most ancient galaxies ever recorded, scientists detect what appears to be an unusual energy field, pulsating in ways never before observed. At first, astronomers assume it's merely a distant quasar or an unknown cosmic ray interaction. But as more data comes in, the pattern of these emissions suggests something radically different. The energy seems to be emanating from a structured source, possibly artificial in nature. This discovery ignites a frenzy in the scientific community. Could this be evidence of an advanced civilization from the distant past, one that existed before our current understanding of cosmic history? A team of astrophysicists, led by Dr. Evelyn Carter, a rising star in the field of theoretical cosmology, proposes an audacious hypothesis. What if this energy signature is a remnant of an ancient intelligence, one that predates even the oldest galaxies JWST has detected? If so, it could mean that the universe has harbored intelligent life far earlier than human scientists ever thought possible. As astronomers rush to reconfigure JWST sensors for a deeper analysis, a new anomaly arises: faint but distinct signals embedded within the energy field. The signals appear to follow a mathematical sequence, one that suggests deliberate design rather than natural cosmic noise. The scientific world is thrown into chaos. Meanwhile, debates rage between physicists and cosmologists. Some argue that the signals are merely a product of an exotic cosmic phenomenon yet to be understood. Others insist that these could be relics of an ancient, hyper-advanced civilization that somehow thrived before the universe as we know it even came into being. Then, another breakthrough occurs. A group of linguists and cryptographers working alongside astronomers manages to decode part of the pattern. It is not just a signal, it is a message. And its translation is as simple as it is terrifying. You are not the first. What does this mean? Was there a civilization before us, one that witnessed a universe older than our own? Had they left this message as a warning or an invitation? As the world grapples with the implications of this discovery, space agencies across the globe mobilize. A special international mission, codenamed Project Origin, is formed to investigate further.